to an audience that many of you may know more than I do about this subject that I've chosen, but the presentations that we've had, the discussions that we had throughout this month were all directed to the idea that we're a group who is more interested in learning how to live in this world than we are worried about how we're going to live in the next one or exactly how we're going to get there. And I think there's probably as many ways for those people who want to go somewhere else to get there than there are ways for us to eat a healthy, well-balanced diet. There are just many ways to do it. First off, I understand that for people who are going to present information, they have to somehow justify to their audience that they have some information to give you. So I'll tell you right off the bat that I have gone through these courses that you can get from the great courses: Medical Myths, Lies and Half-Truths, What We Think We Know May Be Hurting Us, Foundations of Organic Chemistry, and these are all like 30 hours you listen to people talk about this stuff. Biochemistry and Molecular Biology, or How Life Works. Now, I'm not going to tell you that I've memorized those or I understand them all, but I do know some things. I can pronounce some names that some people can't. And one of the things we'll handle right away is that there are people who say, they name some name they can't pronounce, and they say, I certainly don't want that in my food. But as a matter of fact, the chemical names for things are just, the chemists name this so that if they talk to another chemist, that other chemist knows exactly what chemical they're talking about, where the things are attached, where the phosphate groups are attached, where the alcohol groups are attached. And no one can pronounce them, and no one can really memorize them. I mean, maybe if you, when I took organic chemistry in college, I certainly didn't try to memorize those things. I just learned to read it. But one of the things that's important in our nutrition is protein. And the proteins that we need are made up of amino acids. There are a lot of amino acids in the world because chemistry is pretty complex. So are we, but we only use part of that chemistry. So I'll just run down these amino acids are alanine, arginine, asparagine, aspartic acid, cysteine, glutamate, glutamic acid, glycine, histidine, isoleucine, leucine, lysine, methionine, phenylalanine, proline, serine, threonine, tryptophan, tyrosine, and valine. If I mispronounce some of those, I'm sorry. But that part doesn't really matter. The thing is that there are 20 of those that make up the proteins that make up us. And they are not the same in every place in our body. In other words, in the gelatin, that protein that is part of your bones, that makes your bones flexible, that keeps your bones from being brittle like a sugar cube, that protein is different than the proteins in other parts of our body because they have a different function. And so the proteins that we need must have all of the amino acids that we need for our nutrition. And we don't make all of those ourselves. We don't have the enzyme systems that make them. So we don't make lysine, methionine, tryptophan, and maybe there's a couple of others that are low. So when we eat our food, we have to balance that diet with with proteins that have the amino acids that we need. The first time I ran across this or became aware of this, I was working at Quaker Oats, and the term was PER for protein efficiency ratio. And what it meant was when nobody in the food end of these weren't the cereal people at Quaker who were doing this. These were the dog food people and the pet food people who were talking about this protein efficiency ratio. So if you want to make a rabbit food and you don't want to feed the rabbit, you don't want to have to overfeed him, and you want to make sure that all the nutrition that rabbit needs is in the food that he can eat in a day, then you want to make sure that the protein he gets has exactly the mix of amino acids that rabbit uses. So that's when my first introduction to this PER. And one interesting thing happened. I was in Dr. John Bernatovich's office one day, and his phone rang. He was the guy who was designing all these pet foods, but a phone call got sent to him that wasn't meant for him, but it was obviously a lady on the line asking him what she should do because her dog wasn't eating his kennel ration meal that she was giving him. She was afraid that her dog was going to starve. And Bernatovich said, well, ma'am, if I was going to starve my dog, the last thing I'd try to use to do it with would be dog food. If your dog doesn't eat the food you're giving it too damn much. Oh well, that's just an aside. At any rate, there are some things that I wanted to bring up that came up in discussions earlier, or last week and the week before. There was quite a little talk about some chlorinated biphenyls, chlorinated chemicals in our water. And those things are not to be discounted. They're certainly there. They're not good for us. They're there in particular now because high water levels in the river have there's more organic matter in the river water and it doesn't all get filtered out. And then chlorine can react with those organic chemicals and make what they call PFAS, or whatever that initials stand for. I can find it in here. Anyway, the recent consumer reports, which I'll have downstairs, if anybody really wants to get into those weeds, can look at it. But there is, if that's what is disturbing to you, is that PFAS in our water, those same chemicals, I'll read this, they're polyfluoroalkyl substances. They are water and grease resistant chemicals that are used in burger wrappers, pizza boxes, and other containers. PFAS, which are also used to prevent stains in carpets and upholstery, are known as forever chemicals because they can take decades to break down. In a new study, researchers looked at PFAS levels in blood samples from more than 10,000 people. The scientists found 5 commonly used types of PFAS in 70% of the samples, and noted that participants who had eaten fast food in the 24 hours before the blood test had noticeably higher levels of PFAS than those who hadn't. So that's one issue that concerns us, but as a matter of fact, why are we aware of that in our water and not aware of it everywhere else that it is? So sometimes my point is that we can get so far in the weeds that we don't see things that are even worse. And one of the articles in this that you can read would be about bottled water, because that's one of our defenses against this. Our municipal water supply, if we don't like it, our choice is to go to the grocery store and buy water. And the main thing that the article that you'll get out of, if you read it all, is that bottled water in the store is several thousand times more expensive than the same quality water you can get out of your tap. There is no guarantee at all that bottled water is better than what you can get out of your tap. Now, it's not universally true, but remember, there are thousands of these companies bottling water, and they're not looked at by the USDA and FDA because it's just water. But they do look at your municipal system. And so when something goes wrong there, they're demanded by law that they call you. That's one thing. Another thing that came up, someone had a bag of potato chips downstairs and said, I think it was potato chips, could have been some other dry snack. And they looked at the expiration date and said, this is terrible, this is over date, we should throw this away. Well, I have some kids who came to my house one day and went through my cupboard and they sorted out everything they thought I should discard, and I put it back in the cupboard when they left. And so I'd like to talk about those best use by dates and what they actually mean. So here are beans that I just bought this morning, and they have a use by date, Best Buy, and it says 17 September 20 L, I don't know what the L means. Or it could be a misprint. But at least it looks to me like this is, they're saying is best if used before 2020. I mean, that's the way I would interpret this. Now, in order to explain the importance of these best used by dates, there are beans that were excavated in China that were 2,000 years old, and they germinated them and they sprouted. So there are some things that these use by dates may be useful for, and other things they're absolutely absurd. The best use by date in this case is they would like one of your kids to come to your house and throw this in the trash so you can buy another one. Or if you do read these things in your cupboard, you might make baked beans tonight or bean soup so that you can use it before that best use date. But in terms of equality, remember this bean wasn't growing to make humans. It had no idea of feeding humans with this protein. It did that, it stored that protein and it stored that starch in a form that would be pretty stable. And in the case of beans, last a real long time and still be useful. You would have to suggest that if you could sprout a bean, it probably is still good to eat. There are other things that you wonder why they bother with these milk bones. Best used by March 6th of 2021. I'm so glad they specified the date in March. You know, there's a certain thing we use in engineering we call being overly precise. When I was going through school, we had slide rules to do our calculations, and you could only do 3 significant figures, and that third one was estimated. And that was good enough to put men in the moon. But later in industry, when we got spreadsheets and computers, there were colleagues of mine who were writing reports and putting things in with 5 or 6 or 7 digits after the decimal point, just because the spreadsheet would have that many numbers in it. It makes no sense. Triscuits. These guys said used by April 20th, no, 2 April in 2020, 2 April, 2nd of April. Now, those things are dry foods. They're as stable as those beans. There's nothing going to happen to them. So that best use date means nothing. Now, it might be more significant to get your diced tomatoes out and see that they say best used by August of 2021. That might have more relevance. It's liquid form, it's protected from light, so you're not going to have the same things. You know, light comes in, damages organic materials, it fades your furniture and your curtains, so it does things. If this were in a glass jar, sitting out where light could get at it, you could suggest that at least the surface of the food that the light was seeing could be deteriorating in some manner. But here it's pretty well enclosed, but it is liquid, so reactions might be going on there. And so I wouldn't suggest that this is as good 10 years from now as it is today in terms of nutrition, maybe even taste or color, I don't know. But to suggest that it would be unsafe to eat 10 years from now is ridiculous. So there's a difference between best used by in terms of is the quality exactly what you expected, is it as good as you want, and whether it or not it's safe. This is perfectly safe and it'll be perfectly safe for a long time. I canned pears with my neighbor, and one year the pear tree had no pears, so we did can pears. I had some left more than he did, and so I took him 12 quarts of these pears. And he said, no, I don't want them, they're a year old. I said, well, what's wrong with a year old? I said, well, they lose their vitamins and it all goes downhill. They lose 2, 3, 4% a year of what their nutritional value is. And I said, I'm glad to know that you know so much about nutrition that you actually balance your vitamin intake with the damn pears. So again, it's okay, he's not crazy, he's just, I call him Micrometer Joe because he would be the guy with a 15 place number up there. That's just being a little too precise for me. Now, here's one I found in mine, carnation milk we don't use very much, and so it didn't surprise me that this was a little out of date. This thing says it's only good until 2017. And this one, I'm certain in terms of safety, is perfectly good as the day was put in there. But if I get this out to use in a recipe, and I will look at it to make sure that it looks all right, that the consistency is what I expect, that it's, the color's gotta be right. I'll look at that because it is milk and who knows. So in this case, I would not be afraid to drink this or use it in a recipe, but I'll be careful about looking at what it looks like if it's deteriorated. Another one I took off the cupboard is this solid tuna, and they suggest I should use this before September of 21, so that's not totally unreasonable. So that's what I get out of those best used by dates. And I think that you can do it any way you wish, but I wouldn't be afraid to eat any of those things. Now in these dry products, the crackers, the potato chips, if they're open and they will draw moisture from the air, so they act as a dehumidifier, if you will. Not very effective, but so they pick up moisture, and they're the first quality deterioration that you see is that they're soft and they're whatever. No one wants to eat stale potato chips. But in terms of safety, there's really nothing that's gone on there that's bad for you. They're too dry, even when they picked up a little moisture, they're still too dry to mold or anything like that, so none of that's going on, but you still might not want to eat them. On the other hand, if you had some graham crackers and the package was open and they'd been there a while in your cupboard and you went there and pulled one out and it seemed to be, have picked up some moisture, you can put them on a cookie sheet in the oven and remove that moisture, they're good to go. Because nothing has happened to that cookie. It's no bacterial action has been going on or whatnot. I made some copies of things that I've read, some of them out of these books and some of them out of other ones. And I have copies of these downstairs. So if anybody really wants to get into the weeds of these things, you can do two things. You can pick one of these up and take it home and memorize it. Or you can, for some time I've had copies of the magazine that has the courses that you can take, these, the great courses. There's some catalogs downstairs and you can always look in there and find any subject that you want to learn anything about, you can get a course from them and do it. If you don't like to read, most of these courses come with a book. I generally read the book because it's faster than watching the programs. But there'll be 30-minute segments that you can watch on with a DVD. And so if you're the kind of person who doesn't want to sit with a book, then you can do them that way. But these are three that I use for referencing for this presentation: biochemistry and molecular biology, foundations of organic chemistry, and medical myths. So some of those medical myths I think are kind of fun to talk about. One of them is there was a great deal of discussion about vaccines, and I have no idea who's right or wrong, except that I think that We don't have polio anymore, and that's a good thing. And we don't have much smallpox. That's a good thing. We started to have measles again because people aren't doing vaccinations, and that's a bad thing. But there's an article here that I made a copy, just talking about how those vaccines are made. It's kind of interesting. And there's, I reprinted the glossary out of this medical myths book, and it just describes all the terms that you'll hear if you are talking about health and food and doctors and that sort of thing. And so they go through explaining what acupuncture is, amnesia, animal magnetism, and whatnot. They talk about things that, cholesterol, for one thing, is a big word, big thing. It has a lot of, people talk about cholesterol all the time. It's a bad thing, you don't want it, stay away from cholesterol. But as a matter of fact, people need cholesterol. If you don't eat cholesterol, your body makes cholesterol. I think I read somewhere that if they dried your brains out and analyzed it, it'd be like 30 or 40% cholesterol. It is absolutely essential to the coating on your nerves so that signals can go back and forth, and yet it has a bad name. And that's it. I know friends who spend a lot of time with a diet where they detoxify their intestine by buying some stuff that they do a 2-day purge, where they eat no food, they eat this other stuff, and somehow or another that gets all these toxins out that have been building up in their body. Well, our bodies just aren't built that way. We have systems that eliminate those toxins, and that's why we use restrooms. and that's where they go. And one thing is that our intestines have a lot of microorganisms in them that are important to our nutrition. And when you take, this is one of the reasons why when you have to undertake an antibiotic regimen to get rid of some infection that you have somewhere, it often disrupts your organisms in your gut, and you end up sick for a lot longer until you get that back in shape. And so those things are necessary for us. Here's something else that I have come to realize is that people are all different. So if you have someone who they're allergic to something, you're not. That's not BS, they're allergic to it. But if someone that you know is allergic to peanuts, does not mean you shouldn't eat peanuts. It doesn't mean peanuts are bad for everybody. If you have celiac disease and you can't have gluten, doesn't mean that no one should eat gluten. It doesn't mean that gluten is bad for people who don't have celiac disease. And just to demonstrate that we are different, you might not know any, but I've found some people who say that when they eat, now I can't think of the, no, it's green leaves and cilantro. There are people who cilantro tastes like soap. And that's not their imagination. And if cilantro doesn't taste like soap to you, that means your genetic makeup is different than theirs. The same way in which if someone is allergic to lactose, it just means their body doesn't produce lactase enzyme, and therefore they can't use that. So we have those differences. There's another one of those flavor things that always astounded me, but now I can't remember what it was. But we are different in many ways, and therefore some of our nutritional ideas might be workarounds for those kind of individual things. There's a great deal of talk about genetically modified food, and it generally, in the general populace, I think probably has a bad name. It's probably misunderstood a great deal. But as a matter of fact, I have down on the tables two articles. One is about how insulin is made today, and the other one is how expensive insulin is today. And the reason it's expensive is the drug companies can simply raise the price anytime they want, because if you need insulin to live, you're going to buy it. But as a matter of fact, the article explains how insulin is made today. There may still be some made from pigs' pancreases, I don't know that. But the bulk of it is made in a fermentation process with Escherichia coli. Could have used yeast, could have used any one of those microorganisms. But they genetically modified that Escherichia coli's DNA so that it produced insulin. And in order to do that, they had to adjust it also make changes in the DNA that created enzymes that would eliminate an excess amount of insulin. In other words, if insulin was building up in that microorganism's body, there'd be other enzymes that say, hey, there's too much of this stuff, we don't need it, we slow it down, quit it. So they had to inactivate that piece too. So now they have this Escherichia coli, the DNA modified so that it makes all kinds of insulin. Find it, the inside of the cell just fills up with insulin. So then you harvest it, break them open, and that's where we get insulin today. So when you think about that price of insulin and the impact of drug companies and the controls they have, you have to realize that insulin should be going down in price, absolutely down in price. Think about it. There are more people with diabetes, so there's more insulin being used. They've now got a very efficient industrial process to make it, and yet the price over the last few years has gone up 14% a year. It's ridiculous. But at any rate, genetically modified organisms. I'm not saying that it's great, it's wonderful, but I'm telling you, if you want to avoid them, you will starve to death. Because all canola oil is made in genetically modified rape plants. I don't know why they didn't change the name of that plant, but they haven't. Most soybeans are genetically modified. So most soybean oil is made from soybeans that were genetically modified. Virtually all corn. If you drive past a field of corn or soybeans and you don't see some weeds, then you know that all that soy and all that corn was genetically modified. There's just no other way to make those things weed-free. I think, I wish that clock was right so I know where I am. But I think we can, do you have any questions about anything? Like how stale can a cracker be and you still eat it? It has to do with how hungry you are.
With all the mold that's in the corn and beans now, will that be transferred to the food, then transferred to us? Will we have more allergic reactions to the food that they're putting through the system right now? Do you think that's possible?
Well, you're not talking about the things that come along because it's genetically modified. You're talking about.
I'm talking about mold and allergies.
I think that the industry does a good job of cleaning stuff up. I never thought that the removing. Well, I know when I was working at Quaker Oats, aflatoxin first became a thing that everybody knew about. And it was a storage mold mainly, but then later they found it in fields, so they realized that's how it got into the storage, because it was in the field first. And they discovered that by accident because some British chicken farms had trouble with the chickens dying. And that's when they dug into that and found it was this aflatoxin, and then they started looking for aflatoxin and found it other places. So that was very carefully looked for. I know that at the companies I worked for, all that incoming grain got inspected for lots of different things. And molds, of course, are one of them. I was always worried more about the rat poop than I was about the aflatoxin, but the thing is that some rat poop floats and some sinks, and that's how you separate it from the corn. Maybe you didn't need to know that. But when you think about it, this stuff came out of the field. It's out in the open air. And if having an insect fragment in your food disturbs you, then never eat chocolate. Never. And here's the reason. All those rules about how many insect fragments you can have in a pound of food or in a can of food. I mean, there are USDA guidelines that says in a 304 can of cream corn, you cannot have more than 0.2 of a centimeter of a corn earworm. Well, that sounds terrible, but you know from experience that you don't taste them and they don't hurt you, and you would not be able to afford corn if they guaranteed you none of that stuff. You wouldn't be able to afford it. So these rules are written with industry input. In other words, what's reasonable? If we really do a good job, what's the best we can do? Then that's our standard. That's what we'll do. With chocolate, the standards is so loose because it's grown in a jungle, it's picked by people in bare feet, it's put in burlap bags and strung around and traveled all over the world. And there's a chocolate factory in Milwaukee, and they would get these bags off the boat in Lake Michigan. I don't even know how it got there. It had to come up the Mississippi. It didn't come up the St. Lawrence. I have no idea. But they take them off ships in Milwaukee, burlap bags, and between the burlap bags they find all manner of stuff. In other words, from the time that was in the tree, getting picked and moved around, it just got worse and worse and worse. And so the idea was there's just almost no way that you can remove absolutely everything from these chocolate beans. So you don't. You just say, what's the best we can do? And chocolate is the worst product from that regard that you can eat. And that proves that human beings cannot taste insect fragments, particularly not if they're encased in chocolate.